Hello, and welcome to day 2 of trigonometry. Yep, I should probably put day 2 here, D2. And in this particular lesson, we're going to still be solving for sides just like we did before. We've covered if you have two sides, you should use the Pythagorean theorem. If you're given special right triangles, 30, 60, 90, 45, 45, 90, then you could use those to solve as well. And in this particular case, we're going to be solving using trig ratios. So we will have an angle to actually work with. And most of the time, we're going to want to round to the nearest tenth or the hundredth. And read the problem, whatever it asks you to do it. Okay? So, trigonometry day 2, you are going to be given, I should say solve for one side given one side and one angle. So this particular lesson is focused more so on trig ratios. First example, solve without the special right triangles. We know that this is 30, 60, 90. We should know that this is 30, 60, 90 because if this is 30, this is 90, the remaining angle has to be 60 degrees. So if we really wanted to, we could put 60 here. And for the sake of it, well, I'll show you how to do it without it first. I take it back. Since we know this is 30, 60, 90, if you know how to do it, it's much faster to use the 30, 60, 90 special right triangle ratios for the sides. So let's do that really, really quickly. We know that 30, 60, 90 always has the ratio of sides as b root 3, and 2b. 2b. And in this particular case, we are given the side 3, which is directly opposite of the 30, which means this is equal to b. So what we could do here is we could say that this is 3, and since we know what b is, we could fill out the rest of this. This should be 3 root 3, and then the 90 side should be 2 times 3, which is 6. So in reality, we should know that this hypotenuse x should be equal to 6. Now, for the sake of understanding this particular lesson, let's pretend we forgot all of this. We did not remember the 30, 60, 90s always goes under the b root 3, 2b ratio. So we could actually do this without the 30, 60, 90 rules. What we would do here is this. I'm going to do a little squiggly here, and I'm going to set up this trig problem as if it's a trig ratio. Opposite of the 3 is opposite of this 30, so we call this the opposite side, and the x is the hypotenuse. So we could actually look at our trig ratios and say which trig function actually has opposite and hypotenuse. If you realize this is sine, we could use that. And our angle here is actually 30 degrees. So we could say sine of 30 degrees is equal to the opposite side 3 over the hypotenuse x. And from here, this just becomes solving for a variable. Very, very important, though, is that we want to make sure that we are in degrees. Your calculator is in degrees mode. I'll show you how to do that right now. So clear that out. Our mode is directly next to the second button. And then if you see, sometimes we're in radians, sometimes we're in degrees. Most of the time you're in degrees. You hit enter, you hit clear, and then you are now in degrees. So to solve this particular equation, you could do one of two things. You could solve as if it's x, and if you really understand algebra, you could just start multiplying x to both sides and then dividing out the sign, or you could kind of treat it as proportions. You could put this over 1, and then you could cross multiply. Okay? So most people will just multiply both sides by x. I'm going to do that here. Multiply by x, and then these x's on the right cancel. So you get x times the sine of 30 is equal to 3. Divide both sides by sine of 30. And then x is then equal to, this is where your calculator comes in. All you do is plug in 3 divided by the sine of 30, 3 divided by sine of 30, close the parentheses, is equal to 6, just like we predicted from the special right triangle. So x here is equal to 6. Okay? And we could say x is equal to 6, and we're done. All right, so that is how you would solve without the special right triangles, given one side and one angle. Now, if we really, really wanted to, we could solve for the last side. We're not going to do that. We're going to move on to example number 2, solving for j and k. So in this particular problem, this is based off of a real-world application, but I broke it down and made this a little bit simpler. We are using an angle that is not 30, 60, 90, or 30, 60, or 45, 45. So this triangle is just a regular right triangle where we don't have a special right ratio. So what we want to do here, since we're solving for j and k, let's solve for j first. From this perspective, 25.7 degrees, we know that the base is 532 feet, and this is the adjacent side. We know that the j is actually directly on the directly opposite of it, so this is the opposite side. And we want to ask ourselves, if you want to put for k, we could write hypotenuse here. If you want to figure out, if we're solving for j first, and we want to figure out, okay, which trig function involves adjacent and hypotenuse, we would say tangent does. So we're going to work with tangent. And since we're working from this angle, we're going to say tangent of 25.7 degrees is equal to opposite, which is j, over adjacent, which is 532 feet. In this particular case, it's actually easier to do because the j is already almost isolated. So all we have to do here is multiply both sides by 532. So if we do that in our calculator, 532 times the tangent of 25.7, close the parentheses, and we get a new value, 256.03. Now, if you notice, I didn't say where to round. I'm going to say round to the nearest, hundredth. All right. So in this particular case, when we multiply, well, 532's on the right cancel. And then we get this value will be equal to 256.03 because the 4 in the thousands place doesn't round up. So we're going to say this is equal to j. This is equal to 256.03 feet. Very important that we actually put feet here. All right. So, k, we also need to solve for k. K can be solved using the same method in which we would look at which trig function involves adjacent and hypotenuse. So what we want to do here is use those values, or use the trig function that has adjacent and hypotenuse, which is cosine. Now, for those of you wondering, can you actually use, for instance, sine here? Absolutely, you could. What I would mention, though, is this. We rounded for 256.03. We rounded that value. So if we use this trig ratio of opposite over hypotenuse, just know that our answer for k will be less accurate because of the fact we rounded for j. Even worse, what happens if we actually got j wrong? Well, that means we are writing the ratio for sine over sine as opposite of hypotenuse incorrectly to solve for k. So what I personally recommend is using the values that are given at all times. especially since this is a whole number. Okay, so I recommend that we actually use hypotenuse and adjacent to solve for this. So in that case, we have cosine of 25.7 is equal to the adjacent side, 532, over the hypotenuse k. From here, just like in the first example of the day, we multiply both sides by k. K's cancel out on the right, and we get k times the cosine of 25.7 is equal to 532. To get rid of the cosine, we have to divide it out. Cosine 25.7 is divided on both sides. Cosine to 25.7 cancel out on the left side, and k is then equal to, and let me clear that out, I'm not sure how that happened, 532 divided by cosine 25.7, close parentheses, and we get a new value. Round to the nearest hundredth, so we would say 0.40. You don't have to put the 0 there if you don't want to, because the next number doesn't round up, and this is in feet. Okay, so, and this should make sense because if you really remember our geometry, I can put 590.40. This is directly opposite. This is the hypotenuse, which means it is the longest side. So it makes sense that it is larger than 532. And at the same time, 25.7 is the smallest angle, and this is the smallest side. So this is directly opposite of the smallest angle and side. Those are paired off. So that should be the shortest side. Okay? All right. So now we know how to solve for missing sides, whether it's Pythagorean theorem, special right triangles, or given one side and one angle in a right triangle. Awesome. Now, if you have any questions, please ask, and I'll happily answer it, and I'll see you in the next one. Bye.